Hello, welcome to this lecture on how to configure a switch and a router which is part of a LAN. So, as I mentioned in the previous lecture, there is a LAN, local area network, and different hosts are connected to it. Now, how do we connect it? Right? We need some network device to connect the host to a single LAN. That's a job done by a switch. Then, if you just have one switch and then you connect it with the ports, ethernet ports or whatever you have in the switch, then what happens is they can be only in within the LAN. They can communicate within the LAN, but they can't go out of the LAN to talk to some other hosts which are in different networks. In that case, the LAN should also have a router connected to it. So let me write it here. We have a LAN. LAN, I am circling it because they all communicate with each other. So logically they are connected like this. It's not that physically they are as a circle. Okay. Now you may wonder how, based on the switch connection, how can you realize this kind of a circular mechanism wherein a host 1, this is, let me call it as a host 1, host 2 and host 3 and host 4 talk to each other. If it is like a ring road, you can start from here and then reach anybody, cross someone, reach there, and then our this guy, anybody can be reached using a ring topology. But when you see a physical connection, we have a switch. The switch can be of 24 ports or a 48 port or 12 port or even 3 ports, right? Different ports are there. That means that many hosts can be connected. Now let us, for a simplistic case of a 4 port switch. Actually in physically you may see 24 or 48 port switches which we'll see in a packet tracer kind of a tool supplied by Cisco, wherein you can realize actually a circuit like this, which I will show you a picture, but we are not going to see the demo of those tools here. So there what you do is you connect ports to a LAN, a machine, right? It could be a laptop or a desktop. You connect it like this, right? It's like a star topology, or just there is no interconnection shown between them. But I say that a switch does a job of realizing a LAN, which is a logical circuit. This is a logical LAN, which is shown like a circle or a ring, and where all the hosts connect to a particular LAN and they all talk to each other. Whereas when you connect to a switch device, we actually in physically also will be connecting it like this individually. Now, how do they talk to each other? So that you need to go into the switch to understand how they have been implemented. Okay, let me take as an example of 4 switch port. Ethernet ports are there. It can be a gigabit Ethernet port, gigi. Okay, it's called in short form gigi. That means it can be 1 mbps of data. It could be 10 or 40 also. We are just discussing about 1 mbps, sorry, gbps. I'm sorry, it's 1 gbps, gigi interface. And if it is a fast Ethernet port, we call it as a fast Ethernet. There are two different speeds that are possible: 10 Mbps and 100 Mbps. Right? We only consider these two, and we call them as a fast Ethernet. This is a better version of Ethernet from, if you go back to 1980s or even further. They are evolved like this, right? It was earlier 1 Mbps and then which became 10 Mbps, 100 Mbps. So compared to Ethernet, it became fast Ethernet. But actually, the faster Ethernets are much more than what you see here as named as fast Ethernet because of the historical nature reasons. They remained as fast Ethernet, though they are only giving you 10 Mbps or 100 Mbps speed, which of course you know that in 10 power x bits per second. Here 10 power 9 bits per second, 1 gigi port. So gigi port is much faster than fast Ethernet, though it doesn't claim it to be fast. Maybe we can call it as a faster Ethernet or fastest Ethernet, but they decided to go with the gigi port because gigabit Ethernet, of course, we all understand that is faster than fast Ethernet. Okay, so now we connected a host to a single line. Is it a duplex connection or a simplex connection? Which I mean by what I mean by that is duplex means the data can be going in both ways simultaneously. So this Ethernet port, whatever you are connecting, we are having a traffic which is flowing in both directions in each of those hosts, host 1 to host 4. But there is no mention of this LAN kind of a interface wherein they are all connected to each other so that H1 can talk to host 1 can talk to H2, host H2 can talk to this, or anybody can talk to anyone. So it's like a broadcast medium internally. Okay, that is realized by maybe a crossbar kind of a switch, bus, not a switch. Inside a switch there is a bus, physical bus, which realizes the achieves the transfer of data between any of them. So that is internal to the switch, wherein you have a means mechanism of transferring data at gigi interface level, gigabits per second speed. The bits are being transferred. The frames are Ethernet frames are being transferred. Okay, so remember that the switch does the job of enabling these hosts to talk to each other at that speed. Okay, now that we understood a LAN, now let us talk about a LAN being connected to another network. Now, what we need is, apart from these hosts which are there needs to be a router, a device, part of this LAN. Remember, a router interface, which could also be a fast Ethernet interface or it could be a Gigi port, it needs to be part of this LAN. When I say it has to be part of the LAN, what does it really mean? We have to go back to the previous discussion that we said that network ID is there. It may be a class A, class B, class C, or in any other division of network ID portion and host ID portion of our IP address. But if a router or different hosts are considered to be part of a LAN only when their network ID portion of the addresses are the same. That's one thing. This needs to be same is one condition. Another one condition is the host ID portion needs to be different. That is also an important condition because they cannot be same here. The host ID portion cannot be same because I have a message. Suppose, see, LAN is like in a room, 5 people are there. If all the 5 people in a room need to have different names for you to communicate. Otherwise, you don't know whether you are calling person X or person Y if their names are different. Then you have to identify some other ways of giving a nickname so that you can still find a unique name to talk to each other. Okay, that's a condition if you want to be communicating within a LAN. Now, why are we bringing a new guy into this world? Because these devices are not happy by discussing among themselves. They want to talk to somebody outside the network also. In suppose you are inside the home, inside the room, you can talk to individual people in the room by just directly talking to them. But if you want to reach out to somebody who is farther away in some other different country and you want to call, you need some mechanism, either a phone, mobile phone, or if it is through laptop you want to communicate, then there should be some mechanism to connect to the network of different network wherein a particular person is currently right now. Please remember, I am saying another person is currently in some network and that logical IP address that person has, that device has, we should be able to reach to them. If suppose the person is in a different country, they will be connecting to some Wi-Fi or some other network, or maybe they are connecting to some service provider of wireless communication and you reach out to them. So there should be some mechanism for you if you are interested in reaching out to some hosts which are outside our network. So you are happy if you are within this, but if you want to communicate with somebody outside, you need a router. Now, if the router needs to be part of this LAN, the router's interface, each interface will be associated with one IP address. Okay, and that IP address will have a network ID which is same as the network ID of these devices. Okay, and then of course I said that host ID needs to be different, so this IP address also will have a host ID portion, though for practical purposes router is not a host, it's a network device. So but still it needs to have a host ID portion which is unique from the different other hosts which are there in the LAN. Then only if the packet is meant for this host, it will be the host ID will say that I am talking to this host ID. But if I am sending a packet to some other host, then I have to now send that packet. Okay, I am suppose let me give an example. Suppose I am trying to reach out to somebody else. My IP address would have been the new, I will call it as a new network ID. Okay, that is not part of the LAN that I am belonging to. I am talking about a destination IP. This is where I want to go, I want to reach, and then the host ID is my original, or whomever is there in that particular network ID, that new host ID. Okay, so now let me draw two LANs. Okay, some routers are in between. Okay, RRR routers, and this is a LAN 1 and this is LAN 2. Now I am constructing a packet which is meant for somebody here. So let me call this network ID as network ID 2 some number, and then the host ID is host ID 2 something, okay, some different number. I will put that as a network ID 2 and host ID 2, and then I want to send it to different LAN. Now this network ID portion that I am sending is not part of this network ID. Okay, this is network ID 1, let me call it as, and different hosts can be there. Now once the network ID is different, the host ID doesn't mean at all. Okay, initially when I am trying to find out whether this packet that I am sending from the host here belongs to this LAN or not, I decide by looking at the network ID portion. Okay, first remember, I don't even look at the host ID portion. That's why we normally use the subnet mask to extract out the network ID, because we want to know whether are you talking to somebody, maybe maybe a name called Ravi. Okay, this Ravi is a host ID. Suppose, are you referring to somebody inside the room, Ravi, or someone else in the some other network, Ravi? So unless I am sure, are you referring to whether a person inside this LAN or not, I don't even look at the host ID portion. Okay, so the network ID portion now will tell me whether I am communicating with somebody in the local LAN. So if it is different, that means I am talking to someone outside of this network. Okay, I'm not talking. I'm not. This packet is not destined to some host within the LAN. Then what happens is, let me talk about that now. So we have a switch, okay, which is enabling us to talk and connect different hosts in a LAN. There are occasions wherein you may be communicating only within you, and there is an occasion that you generate a packet which is supposed to be destined to go out. Now, that packet that I am generating will have a network ID portion. I am calling it as 2, something which is different from the current network I am part of, which is, let me call it as ID 1. It could be 2, 3, 4, something, okay, other than this. Then it shows that this packet is not destined to somebody in the LAN. But do I change this to say that, okay, now I have a router, I know that I have a router which is going to help me to send this packet out, and then this host ID portion, whatever I have mentioned, will become valid when the packet reaches that network ID 1 that I am referring to. Once that packet reaches there, then it becomes valid. Now within this network ID, what is the host that I am interested in? Then that switch, whatever is the switch, okay, will take care of. Finally the router which is connecting this particular network will take care of routing to the particular host. Till then I am not interested in knowing the host ID portion at all. On the way also I am interested in searching for the network which is referred by this particular IP address to reach that place. It's like you are sending a post from a city, Bangalore city, to Chennai. Now, when you have Chennai to Chennai, I will look at the street name and pin code and door number only after I reach the letter has reached the Chennai post office, central post office. On the way from Bangalore to Chennai, I don't care about which street are you in Chennai. Let me first take the letter to the city that I am interested in, which is similar to our LAN. Then I look at the host ID portion to see where exactly in this LAN which host I am supposed to deliver this packet to. So, in coming back to the situation wherein I am going to some outside network, I realize it by looking at the network ID portion of the IP address, which is different from my local LAN. Then, how do I know to which IP address I need to send it to? That's where your default gateway comes. So, this default gateway, I mentioned that it is part of this LAN and its IP address will have again same network ID portion and host ID portion. Though the host ID is for naming convention, we are calling it as host ID, but it is not a host. You know that it's a network device and which is having a special functionality. It's not like a normal laptop. It could be a machine like a laptop, but it has a mechanism of routing protocol running and this functionality is routing. So it is different. So we will give in normal networking terms a unique host ID for a network device. Normally, it is given a lowest host ID, valid host ID within the LAN is assigned to this. It's not that you have to give it, you can give any host ID, but any network administrator would allocate host ID portion, which is the lowest host ID portion, which is normally 00 is not valid. Whatever may be the width of the host ID, the 01 is given. Now, suppose if I have in the same LAN, I have multiple routers. I cannot give one to all of them, right? It's not that it is frozen that I need to give only one. It is not that host ID cannot be different from one for any router. No. But if you have only one router in a LAN, yes, I would recommend that you put one to that particular router and the host ID portion is this. What will you give it as a network ID portion? That is, if this router is part of a LAN, which is having a 10.0.0 maybe, or 10 is the host ID, network ID, or 192.168. maybe 10. Then that is a class C address, which is 24-bit wide network ID. Then I will give this as a network ID and 01 as a host ID as an IP address to the router interface. Now, who decides to send that packet to this? Yeah, there is a software running there, and the switch realizes that yes, or even the device also routes the packet to the default gateway, which is assigned to the IP address of this router interface in the LAN. Okay, so that's what I'm going to talk about now. When you want to send a packet out, which is interested in communicating with somebody outside, it is not going to change the IP address to the router's interface. But if the IP address is within the LAN, it may give the same IP address of the machine which is connected here. But if it is somewhere else, that network ID and host ID will be different, and it will be different from this IP address of router interface also. But the packet is taken to that guy, and the router is the responsibility is to deliver it to somebody outside, or deliver the packet to the network to which it belongs. So let us now, having understood this fundamentals clearly, let us understand how a typical circuit network diagram looks like. So this I have taken a screenshot of packet tracer, which is a very wonderful tool to simulate and test them. I'm not going to go into details of how to connect them. Here, let me say I have a network and its mask is this. Then within this, you can know that once you see this, you can say that it is a /8 notation. The first 8 bits are network ID and the remaining are host ID. Now I have decided to give 0001 because I can give any number in this 24-bit 2 to the power 24 minus 2 maybe. I can give any host ID, but I have decided to give 1 for this interface because I told you that if there is a one router, only one router in the switch which is taking care of connecting all the machines in the LAN like a ring topology, and anybody can talk to anyone. And if this device is trying to ping any host which is outside of this network, then that packet, ping packet, ICMP packet, is going to be routed to this guy, and this is going to take it out to some other interface. Always remember, a router, if it is performing a routing functionality, it needs to be at least part of two network, right? Otherwise it cannot, it's nothing different from any host, because this host is part of only one network. Similarly, if network is not router is not part of two network, it cannot perform a job of routing it, right? So there should be at least two interfaces on two different networks to do a job of routing. Now in this case we have the network, which I am not going into the details of what is the network ID and IP host ID portion of those addresses. Let us try to understand one part of it. So this IP interface, if I say that this is my IP address, or a network ID portion is 10, then I will tell that I will assign 001 as a interface IP address to this. You have to assign the IP address to this interface, as well as on each of the hosts you have to do two things. One is assigning IP address to each of the machines, the logical address of these machines, which are of course part of the same network, and I am giving unique addresses like .2, .3, .4, maybe .5. You are free to use anything between 1 to 1 is anyway taken away for router. So 002 to 111 is all 255, which is also not allowed, 254. So you are free to actually use any number between 2 to 254 for these devices. This, but as per standard, you are going to give one as a host ID portion. In our if it is 8-bit, okay, please remember this is a host ID portion is 8-bit. Now in our case it is 24-bit. Then you are having much more flexibility in deciding the host ID portion. From maybe I will call it as 1 is not allowed. So 2 to the power 2 to 2 to the power 24. Okay, is minus 2 you have to put, because 2 to the power 24 is outside of this 24-bit limit. It is 1 is here. So 2 to the power 24 minus 1 will give you all ones of this, which is a broadcast address. So I am subtracting 2 so that I get the next number, which is all ones, 24 bits followed by a 0. Okay, the next lower number from the highest number. So that will be this value. So you can give any host number in this range, but humanly possible to interpret it if you give meaningful numbers. So 2, 3, 4, 5 is what we are taking. Now what should be the default gateway of each of those machines? That you have to understand. That needs to be the same, which is this IP address. Why? Whether this machine wants to talk to somebody else outside the network, or even this machine wants to talk to somebody else outside, it needs to go through this path. Okay, if there is a highway and there is a city you are interested in, there is one exit. Okay, normally on our Indian roads exit has to be here. So if exit is there on the highway to go to a particular city, all the cars coming here, if they are interested in coming to this city, they need to take this exit, right? So that's how this exit is there within this LAN or city for you to communicate to outside, communicate to the machines which are outside of this network. So every device in this LAN needs to be having a configuration which is called default gateway, that needs to be same as whatever you have allotted the IP address of this router interface to be. If I have allotted 1 here, 10.0.0.1, I need to write default gateway like this. Suppose because of some reason I am not interested in giving 1 here, maybe I have put 100, which is not conventional, but you can still do it. This circuit will work. If I have given 100, then I need to make sure that default gateway on all the machines I give 100. Default gateway configuration. And also you should remember, when you are allotting unique IP addresses of these, which are all part of this network, for them to be part of a internet, they need to also have an IP address, and they also need to have a 10 dot as a starting network ID. and I need to make sure that I don't give 100 to them, any of them, because I have already taken up that 100 for my default router interface, which default gateway or a router interface connected to the switch, which is enabling you to be a part of the LAN. So on all the devices, if I have chosen the IP interface of IP address of this router interface as 100, 10.0.0.100, then I need to set up that default gateway value as 100. So I urge you to try out all these things in the Cisco packet tracer to understand it better. There can be two devices in the LAN or maybe three or four devices. Then the configuration should be like this. Now, a network can be defined. Now, who decides the network's IP address? It actually could be configurable if you have a DHCP running, dynamic host control protocol, but we are not getting into the dynamic host allocation. Now, configuration, sorry, dynamic host configuration protocol. So, for a moment, we are talking about static IP addressing. That means IP allocation. I am deciding the IP addresses as an IT administrator, that this is what is your name. It's like by birth, your names are decided. It's not that someone else is giving you. It's your family decides the name for you, right? That is what is done as an IP administrator. When I am connecting a machine to a network and a switch, I decide that okay, you get this IP address. It's not that randomly decided. It could be a lot of logic goes into it. But right now, assume that you decide the IP addresses of the network ID portion of the particular network, and then you decide the host IDs. Okay, that is purely random. It's not that I need to have always this host ID number should be smaller than this host ID. No, it can be any order, anything, as long as they are unique and they are not clashing with the default gateway that you have decided, and all of them have the network ID portion which is same. Okay, that's all is the condition, and the host ID portions are different. That's it. So this is how you configure a, a host within a network. What all need to be done? You need to allocate the network address, IP address, sorry, and then the default. Sometimes when you are using the standard dividing the network address into bytes, okay, the network ID portion and the host ID portion, if it is the boundaries on the byte boundaries, then the Cisco packet tracer will automatically generate that. Otherwise, you need to specifically say 255 dot, maybe I can write 254 dot something, okay, in between some other 128, some subnet mask can be something different. Now, one thing you have to remember, that subnet mask always starts with 1 from the MSB side, and then it's all contiguous ones. Once you stop, once you introduce a 0 here in the subnet mask, the rest of it will remain all zeros. You cannot say subnet mask which is 255.0.255.250. No, this subnet is not a subnet mask, because there is a 0 coming in between. That 8 zeros are coming, and then you say you cannot divide the network ID portion into two parts. You can, the network ID portion needs to be all bits together from the MSB port together, contiguously. Then the host ID portion starts. Is nothing. Some part of the IP address I take as a network ID is not the standard way of allocating the network addresses. So this is how you configure it. So now let us just take another example, just for the completeness sake. I'll show you one more example here, which gives you different networks connected to a router. So now this gives you whatever was taught in the earlier um, discussion. This is a class A because the /8. This is class B because of /16. That means you have the top two, 16 bits are 255. 250, okay, and then this is class C. Now what is these numbers are? These are all the some standard IP addresses given in this class B and class A, class C. Okay, we will discuss this later on. Okay, normally this is what is, it's not that 10 is also frozen, it can be something different, but 192 168 is stand. Normally you will see when you log into different networks, if you are logging into class B address, maybe you will see the network ID portion is 172.16. You may wonder how come this address is coming up in every network that I am part of, because these are all internal IP addresses, okay, and which is not exposed to the outside world, and what is exposed to the outside world is external IP addresses, which are unique across internet, but internal IP addresses are known within the LAN. So it's like you may have a family nickname which is not known to somebody outside of your family, right? You will have a standard official name outside and nickname in the home, right? Similarly, these internal IP addresses are known within the LAN they are part of, and the nicknames can be same, right? At different families, many people call the say, baby as Chitu or something, which is many families will have Chitu there. But when you go out, you will have unique names given to you officially, and it has a last name and first name, even middle name, and this is how even IP addresses manage like human beings. So I hope this is clear how a router interface is part of a LAN and how different machines on LAN communicate with outside world. What is the default gateway that you need to mention in the machine, and how you have to take care of uniquely giving a IP address to a machine within a LAN. That's the focus of this discussion, and we stop here. Bye bye.